You can design forward from what there is, or you can design backwards from the problem that you're seeking to solve. So as a consequence, our starting point was to design from the problem back to today rather than from pre-existing solutions and making some amendment or change to those existing solutions. So when we start the process of designing systems, systems create path dependence. If I establish a system, then everything that I build on top of that system is predicated on the system. Right? So I become, as an individual and as a society, increasingly invested in that system. So if we're going to design systems, we need not to predicate that design on what is, but rather what will be future circumstances. So today we have an electricity system, for example, which is predicated on a three-phase sinusoidal waveform at a given voltage and a given frequency. We're still living inside the designs of previous generations. Now, if I want to be able to design a system, then I want to be extremely mindful of what the future circumstances are likely to be. So we need to start by understanding the fundamental laws of physics as they constrain what we're seeking to design. What we know for sure are the laws of physics, the laws of nature, are highly unlikely to change. Where the laws of humans and the technology we use to exploit the laws of physics and the circumstances that arise are subject to change. So at all times when we're designing systems, we always have to start by designing from the physics first, because it's the only thing we can be certain of. So if I want to design for a future in which really non-trivial things will be uncertain, and other things, like the fundamental laws of physics, will be completely certain, then I have to have a mechanism by which I can define that negative space. And out of that should emerge the nature of the solution that I'm seeking to resolve for. So now I've got two things to guide me. A certain set of laws or rules, being the laws of nature, the laws of physics, which are subject only to discovery. So I know what I know, and there may be more for me to know, but they're certain in their nature. Secondly, there are the laws of humans in terms of how we govern ourselves and the rules by which we operate. So we need to meet the regulations and standards, and we have to meet the expectations of individuals in a safe and secure approach that is appropriate for humans to interact with. And then I need to be able to assume in a certain state of technology. And technology, just like the laws that govern our behaviours, are just rule sets. So I can do two things. I can understand the technologies that are available today and the technologies which are likely to become available into the near future, and those technologies which are likely to fulfill a function into the future, because I can understand the rule sets and value those rule sets can deliver to everybody. When we start as ENODA to design solutions like the prime exchanger, like ensemble, we start by asking ourselves, what are the constraints that will apply to that future circumstance of a system and of a technology in that system, which can be defined by the things I know that will be there. That will be the laws of physics, the laws of human conduct, and the state of technology now, and the state of technology which is most probably going to exist to enable us into the future. So the capital base of society 138 years ago, when William Stanley invented the transformer, didn't have a pre-existing system of wires and consumers and all of the invested capital that consumers have made in refrigerators in their home and cooling units in their home, and all of which assume a supply of an alternating current waveform. So we now have a global economy which is predicated on the input of an alternating current waveform. So whatever solution we're going to deliver to resolve the energy trilemma, delivering reliable, cheap, and clean energy to consumers has to be one which assumes in that sinusoidal waveform. The world simply can't afford us to scrap all of that capital infrastructure and create a wholly new system for providing energy to consumers. We have to start by looking into the future, understanding what are the constraints that physics provide, what are the constraints of the existing technology which assumes that set of physical circumstance. That is to say, I'm going to assume a sinusoidal waveform in a physical universe in which electromagnetic forces exist. And then I'm going to assume that I need to be compatible with both today's regulatory environment, perhaps with some modification, but that I'm going to be suitable to meet our expected regulatory environment, our expected legislative environment, and the way that we deal with each other as human beings and consumers into the future. I've got a really strict rule set which defines the environment in which I'm going to operate and I'm going to design into. And out of that then, I understand that I have a system which I need to be able to coordinate across the system as a whole. So I have to have a protocol which is able to be extremely reliable and secure because our lives depend on that reliability, which is important in the context of the normal operation of our societies. But also it's a point of vulnerability if and when there is conflict. So I need to ensure that my energy system is resilient as possible, as reliable as possible, even under the most extreme circumstances.